Okay, in 2.1, we're going to be drawing a 3D box and kind of talking about different lines in it. So you might want a ruler and a pencil to be able to do this. Okay, so my first box, we are going to do a, let's do a 9 by 9. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then I'm going to go 3 out. So 3 across. 1, 2, 3, 1, 2, 3, 1, 2, 3. And then this one, since it's the inside of my box, I'm going to make it dashed. And then I'm going to start connecting my vertices. If this goes too fast, go ahead and reverse it and slow it down so that you can be able to do it. Okay, I'm making all my dashed lines, the parts that are the inside of my box, so I can make it kind of 3D here. And then we're going to go ahead and label certain parts on it. Okay, so these are the parts that you're going to label. So A, B, C, that's a D, G, H, and E, and then we're going to answer some questions on it. Okay, so will A, D, and C, G ever intersect the space? Why? So the lines, if it's a 3D box, if I look at AD, that's on the front side plane, and CG's on the back side, they will never intersect. Okay? Because it's 3D, you have the one on the front side and the one going up and down on the back side. So now to check the next sets, I'm going to use a highlighter. So I've got BC and AE. Okay, because it's a 3D plane, the one's on the front side and the other one's on the back side, they should not intersect. So we got another no. Okay, there's not a whole lot of space on your packet to be able to answer these questions, so try to answer them as before I do. Okay, GH and DH, so GH and DH, they run into each other at point H, so yes, they do intersect. Okay, CD and DH, so CD, DH, okay, they're intersecting at D, and you can kind of see that if they share that letter that they're probably going to intersect. So my next set most likely will not intersect. So AB and DH do not intersect. The one's going on the top along the lines and the other one's going top to bottom on that DH line. Okay, so will they intersect? No. Alright, parallel lines are coplanar, means they sit on the same plane and they will never intersect. We have the symbol is going to be this, so in your symbol box you're writing those parallel lines. If you want an example from our screen before here, if I go ahead and erase some of this. Okay, so an example of parallel lines would be, let's say, BC and AD. They're on the same plane, but they're never going to run into each other, so the way that I would write it would be BC is parallel to AD. Okay, skew lines are not coplanar, they're not parallel. Okay, they are not parallel. They can't run alongside each other and they cannot intersect or be on the same plane. We have no symbol for this, but an example on here. Okay, if I pick a DH, I have to pick another one that won't be running the same direction, okay, can't be parallel and won't run into it. So BC is an option of it being skew. It's not parallel, it won't run into it. So BC and DH will be your example from this. So BC and DH. And we don't have a symbol for that, so just write that in your symbol. Okay, parallel planes are planes that do not intersect. They just run alongside each other. So an example from this, I could say, if I want to talk about this top plane, plane BCD is parallel to plane EHG. So plane BCD is parallel to plane EHG. Just need those 3 letters that make it up. Alright, name 3 different lines parallel to DH. So I'm going to highlight the ones that they label here. So that's my DH. You can see that CG runs the same direction. You could see that AE runs the same direction, and then BF runs the same direction. Okay, skew lines to DH, so here's my DH, so they can't be parallel and can't run into it. Remember, this is a 3D surface, so this green one's actually sitting on the back side. It's not running into it because it's 3D, and it's not parallel. This yellow one also sits on the back side. Since it is 3D, it won't run into it, and then we got this one over here. Another option that we could have had was BA, okay, because BA will also not be parallel and not run into it. Okay, name the plane parallel to ABCD. So ABCD is that top one. We kind of already discussed this. Plane EHG is going to be that plane that's parallel to it. Okay, a transversal is a line that intersects two or more coplanar lines at distinct points. So it's a line that's going to be intersecting. A lot of times we're going to see two parallel lines, and we're going to call that a transversal. Okay, in our transversal we have alternate interior angles, so they alternate the sides, so one on one side, one on the other, and they sit on the inside of the parallel line. So alternate is going to be what is going to be doing on the transversal. Okay, so that T that's cutting into it, they're alternating. So one on one side, one on the other. And then the second word is going to be talking about what's happening within the parallel lines. Okay, so alternating and sitting on the inside, so angle 1 and angle 2, and these will always be congruent. So angle 1 is congruent to angle 2, and then my other set is 3 and 4. So angle 3 is congruent to angle 4, okay? One angle has to be touching one of the parallel lines, the other one has to be touching the other parallel line to be able to get this to work. So 1 is touching this parallel line, and 2 is touching the other parallel line. That's why you can't do 1 and 3, because they're both touching the same parallel line. Okay, same side interior, so it sits on the same side of the transversal and on the inside of my parallel lines, so 7 and 8. And these ones are actually supplementary, so they're going to add to B180. The way that I remember it is S is the only one, or same side interior is the only one that starts with S. So if you think S, think supplementary. Okay, so angle 7 plus angle 8 equals 180. And then you also have 5 and 6. So angle 5 plus angle 6 will also equal 180 degrees. It's the only ones that's supplementary unless they make a line. Okay, corresponding is that we call the elevator one. So this one's the trickier one. So if I put, like, this is my level, and I'm starting with angle 4 here, we move up to the second floor in the exact same spot. That gets me to angle 3, and these will also be congruent. So angle 3 is congruent to angle 4. If I take my elevator and I start at 2 and I go up a level, angle 1 and angle 2 are matching. Okay, and then we have two other options. So if I would put 5 and 6 here, I could start at 5 and go down a level to 6. Those are also congruent. If I had 7 and 8 here, if I started at 8 and wanted to go up a level, 7 would be its match. Okay, alternates the transversal, sits on the outside of my parallel lines this time, so 5 and 6, and they will be congruent again. Okay, because the only one that should be supplementary is going to be the same side interior, and then alternating that transversal sitting on the outside of my parallel lines, it's going to be 7 and 8 as your other one. Okay, vertical angles, if I do my little transversal here, remember, vertical angles always sit across from each other and are always congruent, so sometimes you might see vertical angles in here. Okay, so 2 and 4, you also have 3 and 1. Remember that they're congruent. We have 5 and 8, and then we also have 6 and 7. Okay, so just remembering that we have vertical angles and that they're congruent in transversals as well. All right, if the measure of angle 2 is 4x plus 7, and the measure of angle 7 is 5x minus 13. Okay, these are alternating that transversal and sitting on the outside of those parallel lines, so I know that they're congruent. If they're congruent, we can set them equal. So 5x minus 13 equals 4x plus 7. I'm going to subtract my 4x to get x, and then I'm going to add 13, so I've got 20. Okay, my next one in here, it says angle 5 represents 68. And then it says angle 3 represents 3y minus 2. Okay, they are sitting on the same side of the transversal on the inside of my parallel line, so it's same side interior. Since it starts with an S, this one is a supplementary. So I add them, and I set it equal to 180. They're supplementary. Okay, so negative 2 plus 68 is 66. We're going to subtract that 66. Get 114. Divide by 3. We're going to get 38. Okay, my next one here, they sit on the same side of the transversal on the inside of my parallel line, so they're supplementary because they're same side interior. So I add them, and I set it equal to 180. So I got 5x plus 30 equals 180. Subtract 30 from both sides, we get 5x equals 150. Divide by 5. X is 30. Okay, they alternate the transversal, sit on the exterior or outside of my parallel line, so they're alternate exterior angles, which are congruent. So I can go ahead and set them equal. So I'm going to subtract x to get my x's all on the same side to get 6x. Divide by 6, my x should be 8. Okay, they sit on the same side of the transversal on the inside, so same side interior. So this is the only one that's supplementary. So we add them and set it equal to 180. So I've got 3x minus 9 equals 180. Add 9. I combined 7 and negative 16 to get negative 9, and 2x plus x to get me that 3x. Then I added that 9 over to get 189. So 189, and we're going to divide by 3. So my x will be 63. Okay, this one, we're going to forget about the one side and just focus on this transversal and this parallel line. Okay, with my parallel lines, these are alternate interior angles. Alternate interior angles are always congruent, so angle 1 is going to be 76. So don't even worry about the other half. Okay, now we're going to focus on this one, and we're going to forget about the left half. Okay, because I got a new transversal and a new set of parallel lines. Well, these are same side interior, which are supplementary. So if they're supplementary, I have to take away that 119 from 180 to get my angle 2. So 180 minus 119 will get me 61. So kind of forget about the one transversal, then work the first one, then you can work the second transversal, but only really worry about one until you get to the other. Okay, so if I extend these parallel lines, it's not even touching that transversal, so we're going to ignore it. Let's extend our transversal, okay, and we're going to ignore that top half. So if I look, these are my elevator ones. I'm jumping from one level to the other. My elevator ones are corresponding angles, which means they're congruent. If they're congruent, I can set them equal and solve. So I set them equal. We're going to subtract x, and we're going to get 2x. Oops. We can add 5 to both sides and divide by 2. Our x is going to be 30. Okay, then it says find the measures of the angle. So if I go ahead and plug it in, 30 plus 55 is 85, and since they're congruent, they should be the same. But you can go ahead and double check your answer. So 3 times 30 gets me 90, minus 5 is 85 again.